the concept is this. If you see a limit in an indeterminate form, and by the way, you might be wondering, why are we talking about this now? It's kind of an add-on. I probably should add it on applications of the derivative because that's really what it is. But it's really in chapter 9 of our textbook, so, and it's the only thing we do in chapter 9, so that's not really related to areas and volumes, okay? So if you're wondering like, what? That's why we're doing it. It is the AP exam and it will be on your test. Okay, here's the idea though. If you have something, especially in fraction form, there's other indeterminate forms too that you study in Calc BC, and I list them here in a second, but the one we're going to focus on is fractions. If you see fractions where you get a 0 over 0, is this sounding familiar? Remember that we did this at the beginning of the year? A lot of times what you can do is we did like factoring, rationalizing, and we removed it, right? An easier way is it's possible, well, this statement is true, it's possible by taking the derivative of both the numerator and denominator, we can eliminate that indeterminate form. And so the premise of L'Hopital's rule is pretty important because this doesn't work, like we've talked about how you can't just divide derivatives normally, right? This isn't a derivative though, this is a limit. So what I'm saying is the limit of f of x over g of x is going to equal the limit of the derivative of those things. So what can happen is if I get an indeterminate form, I could use L'Hopital's rule to possibly get rid of that indeterminate form. And you want to make sure on the AP exam, because they usually ask a little itty bitty, I'm going to show you on our multiple choice, but they usually ask a little part of a free response, is that you actually make sure you're showing this statement, okay? Because then you're showing them, hey, that's what it is. All right, here are some examples of indeterminate forms. 0 divided by 0. Infinity divided by infinity. Those are the two that we're going to focus on. But if you would ever take a calc class in college, which maybe some of you will, also, what's 0 times infinity?
0.
I don't know, is it? What's infinity minus infinity? What's infinity to the 0? What's 1 to the infinity? What's 0 to the 0? So they're not, I know. So L'Hopital's rule can be used to identify or find limits of all of those indeterminate forms. But like I said, these are the two we're going to focus on.
I just don't understand how 0 to infinity is an indeterminate form. Is it 0?
It's not always 0.
Well, any number times 0 is 0.
Yeah, exactly.
So you're defining a different number.
Yeah.
But if you said
It doesn't matter what the undefined number is.
Well, we're not going to get in a debate about that unless you want to take Calc 2. All right. So let's take a look at this one. Let's first go ahead and try to evaluate the limit by direct substitution. And we do that. So this is equal to the natural log of 1 over 1 minus 1. The natural log of 1 is 0 over 0. So we get an indeterminate form. Okay. That's what I mean by an indeterminate form. So what I'm going to go ahead and do is write that the limit as x goes to 1 of ln x over x minus 1 is equal to the limit as x goes to 1, and now I'm going to take the derivative of both of those things because that's what L'Hopital's rule does. Ooh, so what? I have to remember things? Yes, you do. So now remember this is L'Hopital's rule. This isn't quotient rule or anything. We are assuming, we know that this is true. You're going to just trust me that you know that this is true, that if I don't have a form I can determine the limit, I can take the derivative of both things. You do have to write this statement though. The limit, and you show me the derivative, is 1 over x. What is the derivative of x minus 1? No, not antiderivative. Go forward. Just 1. Okay. So we're going to write what that is. Now let's see if we can evaluate our limit. 1, oh, I can. It's 1 over, what do I put in for x? I'm finding the limit as x goes to 1, so I can put 1 in for x. 1 over 1 divided by 1 is 1.
Whoa.
Okay. Let's do this one. Let's just first confirm that this is e to the 0 minus cosine of 0 over 3 sine of 0. Okay, what do we get on the top? 1 minus 1 over sine of 0 is 0. So since I get an indeterminate form, I am going to state that the limit as x goes to 0 of e to the x minus cosine of x over 3 sine of x, you have to write this statement for the grader so they know you're using a L'Hopital's rule, is equal to the limit as x goes to 0, and you can chunk it out in top and bottom if you want to, of, what's the derivative of e to the x? E to the x. The derivative of negative cosine would be plus sine of x. And the derivative of 3 sine of x is 3 cosine of x. Using direct substitution, e to the 0 is 1. What's the sine of 0? 0. But isn't the cosine at 0, 1? So what's the limit of this? 1/3. By the way, L'Hopital's rule can be used over and over and over again. I think I show one. Well, I'm going to do this first, but yeah. Oh, well, here's the deal with this guy. I'm going to tell you this just in general. Even if you have x to the 100th power, that's really large, right? X to the 100th. Something exponential at a certain point is going to always grow larger than even if it's x to the 100th. Right? You just kind of have to conceptually know that. So eventually, over time, the top's going to grow faster than the bottom. So that's going to make this whole thing go to infinity. I know that already. But I'm going to show you how L'Hopital's rule applies here. So in this form, we would get x going to infinity. E to the x would be infinity. X squared would also be infinity, and that's an indeterminate form. So then I use L'Hopital's rule. I really shouldn't do that equals. I'm going to use the fact that this is equal to the limit of, what's the derivative of e to the x? Still e to the x, but what's the derivative of 2x? Or, sorry, I just said it, x squared. 2x. Okay, hold on a second. Don't I still get infinity over infinity? All right, let's do it again. This is equal to the limit as x goes to infinity, e to the, this one I can. I did this because it was what? Infinity over infinity doesn't equal that. All right, so I have e to the x over 2. Okay, I can do this one. I can see then I put infinity divided by 2 and infinity divided by 2. This just goes to infinity. So I said that to just point out that you can use L'Hopital's rule repeated times. Do we need to do any more? You want to do the bottom one?
Do the last one.
Okay, it feels incomplete. All right, once again, do you see how I get, well, I get infinity over negative infinity on this?
Yeah.
Okay, so let's use it. So this is equal to the limit as x goes to infinity. What's the top? 10x over 7 minus 8x. Agreed? Okay, don't I still get infinity over negative infinity? Let's do it again. This is equal to the limit as x goes to infinity of derivative of 10x is 10. What's the derivative of negative 8x? Negative 8. Doesn't matter what I plug in, it's just 10 over negative 8 or 5 over negative 4.